All right. Get this on.
We always had exams on Friday. Oh, we actually have Friday.
Or we have like something else we should bring
Okay. In probability, the big goal is to always find how big your sample space is, because that's your bottom number in probability. Right away at the beginning, I think you wanted to go to this fundamental counting principle, but I made you draw tree diagrams instead.
So could we use this on the quiz?
Yep.
We're about to learn.
Easier.
Okay.
Yeah.
To make the quiz easier.
Not really, the quiz isn't that hard. Okay, so the fundamental counting principle is used to find the number of ways two or more events can occur. So think of it as a way to calculate your sample space for a multiple part experiment. So it can be used to find the sample space size for a multiple part experiment. Part.
Wait, I got a question.
Yes.
And is not mutually exclusive and or is mutually exclusive.
With the, and you are looking to see if they're independent or dependent, or you're looking to see if they're mutually exclusive or not.
Alright.
Okay. Has nothing to do with what I'm talking about right here, though. So, the way the fundamental counting principle works, if event 1 has, let's say, m number of outcomes or possibilities, if event 2 has n possible outcomes, the total ways for those two to happen one after the other do you know what you have to do here? Multiply. So I'm going to take you back to some of the things we've already done and see how we can find that total. So our first example, let's look at the sample space. I mean, I use sample space, but the other phrase could be find the total outcomes. Sample space for rolling 2 dice. Okay. I made you draw this tree diagram, I think more than once. How many outcomes were on this tree diagram? 36. Well, let's see how we can use this fundamental counting principle to get it. So there's 2 dice, so there's 2 events. I like to make these little dashes. You'll see I like to event 1. I'm just labeling the dashes below. It's not a fraction bar. So if event 1 is rolling a die, how many outcomes are on that die? 6. Event 2 is rolling another die. How many outcomes are there? 6. And if you multiply them together, there's 36 outcomes. But that's that tree diagram. You got the 6, and then off of each one of those you've got the 6. That's why it's coming up 36. Yesterday on your sheet, your review packet, one of them said find the probability of, let's see, So these are all find the total. Rolling a die and pick a number between from 1 to 5. How many outcomes will there be for those two things? So it's still two events. The die and the pick a number. I mean, is it absolutely necessary for me to put these labels down here? No, it's just so you guys can see where the numbers are coming from. So how many options are there on the die? 6. How many for the pick a number? 5. So there would be a total of 30 branches on your tree. What's the iPhone code? How many digits are they? 4. Can you repeat the numbers or no?
Yeah.
You can. So, how many iPhone passcodes are possible? And so we can repeat numbers, correct? You're told me, okay. Repetition allowed. So how many parts is this experiment? Rolling 2 dice is 2 parts. Rolling a die, picking a number is 2.
4 times 1.
It's
10.
4. You got to pick a number,
Oh, you-
then pick a second number, then pick a third number, then pick a fourth number. It's a 4-part experiment.
10 times 10 times.
So it's the first number, the second number, the third number, and the fourth number. Okay, how many options are there for each part of the experiment?
10.
10, because we get to repeat the numbers. So you've got 0 through 9, that's 10 choices. 0 through 9, 0 through 9, 0 through 9. So there are
100,000, 10,000?
a 1 with 4 zeros is 10,000 different codes. And how many tries do you get before the phone locks up? It's a small number, right?
4 or 5.
4 or 5.
The news thing is talking about they wipe.
You have to have that thing though.
It clears the phone out after 10.
Settings left.
You said too encrypted, yeah.
So if you hit 10, it just clears the whole phone out, resets it as a new phone. Is that what it does?
Pretty much, yeah.
Okay. Factory resets it, so they lose all the data. So you can see there's 10,000 options for them to try. The probability of guessing it, how would I get the probability of getting that? If it's 10, 10 out of 10,000 would be 1 in 1,000 chance that they actually get the code right. Which is why they're trying really hard to get Apple to give it up. Okay. Let's go one more. Oh, a couple more. Actually, I'll spend a little bit of time here. What number am I on?
4.
4. How many codes would there be if they did not allow repetition? Let's go iPhone codes. But this time, no repetition allowed. I don't know how you spell that. Repetition. Okay, got it.
Oh, God.
So it's still a 4-digit code. So how many options do you have for the first digit? 10. But now we don't get to repeat. So whatever number you use doesn't get used again. So what happens? 9, 8, and 7.
Kind of like factorial.
Kind of, except, yeah. So what is this? Somebody want to give us this number here?
5,040.
5,040 choices. So almost cut it in half. Okay, let's go with one more. Let's say we've got a alphabetic alpha code on a lock with 3 places to fill in.
26 times 26 times 26.
And there's no repetition allowed.
25 times
Just because you said that so quick. So it's an alphabetic code only, so letters only. It only has 3 places to fill in. And we're not going to be allowed to repeat letters.
Is that like double, or just they can't have a double?
You can't use the letter twice.
I like the second.
So, how many letters do we have to pick from?
First
26.
26, so then the next one would be
25.
25, and then 24. Okay, seems pretty easy, right?
What if you were talking about random sequences of letters?
And they can repeat?
Yeah, or not repeating. Like, if you were to organize the alphabet and,
How many ways could you order the alphabet? All 26 of them?
yeah.
That'd be 26 factorial. Because it'd be 26 twice the 31st, then 25, 24, 20, all the way, because you're using all of them and not repeating. So that'd be a 26 factorial. Okay, let's go back. This will be our last one here. Let's go with an area code. Where the middle digit must be 0 or 1, and we will have repetition or no repetition?
Which one's this?
Repetition.
10 through 10.
Repetition. So area code, how many spots are there on an area code?
3.
3, that's our 906. 3 digits on the area code. So if your problem has any restrictions, which this one does, let's actually go with no repetition, because it'll make it a little more challenging. Okay, go to the spot where there's a restriction. Where's my restriction at?
You get 8.
On this middle one. So how many options do I have for this middle one? 2. So I've picked a number to go there. Now it doesn't matter, because I'm going to be multiplying. When I multiply, it doesn't matter where I start multiplying. How many options are there now for my first spot?
8 or 9, depending.
Well, how many digits are there? 10 digits. I've used one of them. I picked a number here. So I've got 9. And then how many are left for the last spot? 8. So if you've got restrictions, go there first, and then think about your no repetition. And whatever that comes out.
Cool.
Okay, are we good with the counting principle?
Yeah.
I like to put the dashes down. You're going to see I do it all the way through here. Let me know when it's quarter after, too. All right, so you talked about that. Oh, not yet. We're moving on to permutations. Permutations are a little variation on the counting principle. Permutations give the number of ways. I'm glad you could make it, Tassie. To order, this is the key word here, n objects Okay, so if I have n objects and I want to order them, like you were talking about ordering the alphabet. So when I switch 2 letters around, that's a different order. It's just what you're familiar with, that n factorial. Which does what? Starts at n, subtracts 1, subtracts 1, subtracts 1, all the way down to 1. So, I will show you where there's a factorial, and we're going to do the NPR here in a minute.
Yeah, I remember that. Oh, I found it here.
Okay. Number 7. So, how many arrangements of the alphabet are there? I think the calculator is going to go into overflow on this one. But we'll go with Dean's question. How many ways can the alphabet be arranged? Okay, we could think of this as a 26-part fundamental counting principle. Dot, 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 all the way down to the 26th letter that I pick.
It's a very big number.
Okay, it's going to be a very big number. You can see why we're not going to write the whole thing out. So how many options are there for the first letter? 26, then 25, 24, dot, all the way down to the, only leaving me with one letter chosen, which is the same thing as doing. This will be a very, very large number. Now your factorial button is found under the scientific calculators. You can probably see it. Is it visible? Otherwise, on the graphing ones, it's hidden. It's under, I believe it's math,
PRE.
and then go over to PRB. Math, and then over to PRB, and you're going to see the factorial button, the exclamation point, and the NPR and the NCR. Is everybody finding that?
Yep.
It's number 2, 3, and 4. Everybody's got it?
What's RAM?
Random integers, random numbers. It's a random number generator. Okay, so what is 26 factorial?
4, 4, 3, 2, 9, 1, 4,
Math.
1 to the 26.
4 times 10 to the 26th power, approximately.
Would we be allowed to write that?
Absolutely. I would prefer that. If it doesn't come out exact, I'd prefer just what would you type in?
Just 4 to the 26?
No, yeah, 4 times 10 to the
Oh,
20.
yeah, yeah.
Okay. Let me make sure.
There's a lot of different ways.
Okay.
What is 26 actually comes out to?
Jody has a job style, so she can tell her other people down, but also she does a job style, so she's fast and lazy.
Okay.
Now, but going back to the secretary,
You there too?
I was a
5 people need to line up for a photo. How many ways are there for the photographer to line these people up? So again, these permutations can be thought of as the fundamental counting principle. You've got the first spot to fill in, the second, third, fourth, and fifth. And we're going to use all 5 people, so it's 5 times 4 times 3 times 2, which is 5 factorial, which is how many? 120. Okay. So you're good with that? Using everybody, it's just that number factorial. Well, let's say I've got those 5 people, but I'm only going to do 3 at a time and line them up. Now how many ways are there to do that? I've got 5 people, but I only want 3 people in the picture at a time. And the order I put them in is a different picture. So if I took the same 3 people and switched the order, I've got to count that.
You have 5 options, but
Okay.
only 3 spots.
Well, you need 5 NPRs. No, I
Yeah.
said the NPR. Oh.
Because the order makes a difference. So order, if the order is making it a different picture, then it's an NPR, as opposed to what's coming. Do you remember what the other one? NCR, the accommodation. So we'll get there.
Which one would be more
So-
active? Combination of
Permutations give you more. So permutations of n objects taken r at a time. Is the NPR button. The NPR can always be done with the fundamental counting principle. There's 2 ways to do it, the fundamental counting principle and NPR. When we get to the combinations, there's no other way to do it other than with the NCR button. So permutations is the fundamental counting principle, kind of in a little button on the calculator. The formula that's built into that button, it's taking n factorial, which would be using all of them, and then it divides by n minus r factorial. So the mathematicians came up with that for us. So if you didn't have an NPR button and you just had a scientific calculator, You could always just do these two things and divide.
Can you imagine all the counting they had to do to figure this out?
Yeah, so all it was patterning is all it really was.
That actually sucks so bad.
You know, you'd probably, if you started really small, you'd see the pattern right away. All right, so let's see what we got here. Let's see what wonderful example I have here for you. Oh, let's go with I'll make it up. Let's go 8 people.
How come sometimes you write the number and other times you...
I don't know. And we're going to pick a president, a vice president, and a secretary from these 8 people. How many different options are there for the club?
36.
Bernie for president.
So, let me show you the 2 ways. I am stuck on counting principle. That's where my brain just likes to go to. I see this as a 3-part experiment. I got to pick my president, my vice president, and my secretary. And I just go for my options. How many ways are there to pick a president? You've got 8 people to pick from. Well, I know I can't have the same person be the vice president, so how many options are there now?
7.
7 and 6. I like this more than I like 8 NPR using 3 of them. Both of these are going to give you the same answer. But let's, if you like the NPR, let's refresh your memory on how to type it in. You have to, let me turn my, you got to get your 8 going first before you go get the NPR. Then go to math, over to probability, NPR, and we're using 3 of them. And then I like 8 times 7 times 6. I think that's a lot quicker. 336 ways to pick that group of 3 people to lead your club.
How do you do it if like maybe one position, like you have 8 people,
Mhm.
you have 1 person for president, 1 person for vice president, but then say you have 3 secretaries.
Good one. Ask me that after we do the NCR. Because that would not be a 6, secretary 1, secretary 2, secretary 3. That would not be a 6, 5, 4. Because the secretaries all have the same duty. So if the 3 of us were the secretaries, it wouldn't matter what order we're in. We're all 3 of us are just secretaries. So that's a good question for after we do the NCR.
I feel like I remember this.
Okay. We got 5 more minutes, and we'll get to. Got that one. We might be done.
Combination lock be called a permutation lock?
What are you doing?
Shouldn't the combination one be called a permutation one?
The combination lock should be called a permutation lock.
It should be called a permutation lock.
Never
But combination...
Good call.
Combinations catch you.
Patience, girl. This is my last thing I'm doing.
I wouldn't just not vote.
Okay, last idea is distinguishable. Permutations. Okay, what does distinguishable mean?
Difference.
There's a difference between, you can distinguish between them. Distinguishable permutations come into play when we have some of the same type of object, like letters. Maybe we're looking at distinguishable permutations of letters in a specific word where I've got some of the letters multiple times. Or maybe I'm planting flowers along a house and I've got some of the same types of flowers that I'm using. So, distinguishable permutations of n objects where R1 are one type, R2 of another, R3 of another, and it can keep going. I'm going to give you a formula here, but I want you to know what I'm talking about first. Let's say I had the letters, capital letters, in the word eyeball, eye.
I remember this.
Okay. If I ask you, how many ways can you rearrange those that are distinguishable?
1.
Okay. Let's first distinguish between the E's. E1 and E2. So that's one way. Now let's switch the letters around. How many ways can I do this? If I leave E1 here, E2, and Y. Okay, I've exhausted everything with E1 in the first spot. Now let's move Y to the first spot. Then I could have E1 and E2. Leave Y in the first spot. I could switch these around. And then how many more options do I have? Bring E2 to the front.
How much more notes are there, like?
This is it.
Okay, this is the last one.
Yep. Now if we were to get rid of the 1s and 2s, now the 1s and 2s are gone. How many distinguishable arrangements are there? Do I have any repeated words?
Yes. Yeah.
What repeats?
I,
EYE repeats here and here, so I'll get rid of that one.
E,
EEY is here, so I'll get rid of this one. And I got 2 ye's. So out of the 6 arrangements, only 3 of them are distinguishable. So you know what I'm talking about on distinguishable? Okay, there's a formula that can get us down, it can eliminate the ones that repeat. And where I'm saying R1 is the number of repeats of one item, R2 is the number of repeats of a second item, R3 is the repeats of a third item. So, to get it, you take your total objects, factorial, like they're all different from each other, and then you would divide by the objects that repeat, however many there are, factorial. And if I have a second item that repeats, I multiply it down here. And I just keep going to however many repeat.
Doesn't even feel like math.
It is. So if I looked at this one, if we got this, how many objects did I have to start with? 3 objects. That would be 3 factorial. How many letters repeat?
1, 2.
But how many of them? 1 letter, and there's 2 E's, so I would divide by 2 factorial.
It's Schwartz, it's quarter after.
Okay. What is? And then I just want to finish up. So this will give us a 3 if we... All right.
Quiz, is there a bunch of stuff about like the cards and stuff?
Not a bunch of anything.
I hope there is. No, I want.
Oh.
So you put together the review and 90% of
Okay. Wait, I got to do one example left, then I'm going to be done.
Oh, come on.
Okay. This is it. Real quick, real quick. Super quick, super quick, super quick.
Schwartz, we need to...
Super quick, super quick. Stay with me.
Math.
10. Number 10. Got
If we don't finish them, then you need to give us points. for all.
15 trees you got to plant in a line along the road. 10 oaks.
Never do this job.
10 oaks. 3 pines. And 2 maple. How many distinguishable ways can you line up these trees? 15 factorial over 10 factorial times 3 factorial times 2 factorial. The only thing is you're going to have to remember to put parentheses here and here. And then type it in correctly. Okay, I'm done. Now the review packet. Get that out.
I have like 5 minutes.
It'll be a very short quiz. Trust me.
Mrs. Schwartz,
What?
can you do number 15?
Can I give answers first?
Yeah.
We'll go page by page. Okay. First one, you should have listed out the 1 head, 1 tail, 2 head, 2 tail, 3 head, da 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 da.
Wait, what? Can we do
I
a tree
did
instead?
that, but I didn't...
Or tree.
I got really...
Oh, I didn't.
Okay. The second one, I hope you didn't draw the tree, but just told me there would be 30 outcomes.
I drew the tree.
Okay.
It was a mistake.
Number 3. You can reduce these. You can have decimals. I've got 2 6. 4 is 2 over 52. 5 is 13 over 35. 6, I did the decimal for it. .0059, and you can see I multiplied 4 over 52 times 4 over 52. And 7 is 23 out of 143. Questions on that first page?
No.
Matt?
Number 7.
Number 7. Okay, these ones you can just grab the right answer. I am looking for someone who prefers brand A and is a child. Because they've got it broken up for me, where is that cell at?
23 over.
Brand A, child, 23 out of 143, done.
Yeah, I don't know why you taught us to do that.
I know, I shouldn't have taught you the long way. I mean, it works, but it's quicker just to grab it. Sorry, anything else?
Nope.
Wait, so we don't include, so we're not just including the people who prefer brand?
Not if you just want to grab the right number.
Wait, that's 3 places for
Because
number
I
6?
grabbed 23 over 50.
That's more like.
Nope. It's out of the whole group.
That's a Holy Thurber time.
That's only if it says like given.
Mm-hmm.
It says and, it says given.
That's what that line thing means.
Yes. Okay, second page. Number 8, 1 out of 60. Number 9, I didn't find the answer, but
Wait, 112. How is it not 112?
1 out of 10.
Kidding.
Okay. Number 9, I've got 4 out of 52 times 4 out of 51, but didn't get the decimal yet.
0.006.
10, 4 out of 52 times 3 out of 51. Call it good. Number 11, I came down to 28 out of 52, but didn't get a decimal there yet.
0.538.
12 is 4 out of 38.
I put decimals on everything.
That's fine, but show me the fractions. It's easier for me to see if you did it right.
Oh, I have both of them.
13 is, I came out to 16 out of 52.
I like percentages.
I mean, I don't care what kind of answers you write. I'll have them all on my key, so whatever makes you happy. 14 is 26 out of 52.
Totally bad mixed numbers.
And 15 is 1. Questions on page 2.
Yeah, can you do 13?
13. You select a card, find that the card is a 3. How many 3s are in the deck?
4.
4. On the club, how many clubs are in the deck?
13.
How many 3s are also clubs that you
Oh,
double counted?
Okay, so that means not mutually.
Not mutually. Always think when you add, do I have to subtract anything?
Okay.
Only when you add, you have to worry about that?
Yes.
Promise.
And then
Promise.
Same thing for 11?
Yep.
Okay.
11, yes. How many 8s are also black? 2 of them. Matt?
Okay, how do you determine if it's mutually exclusive?
Then they don't have any overlap. Like here, the 3s, I've got the 3 of hearts, 3 of clubs, 3 of spades, 3 of diamonds. And then the clubs, I've got ace through king of clubs. Are there any cards the same in both events?
So they
They are not mutually exclusive if they have something in common.
So, like, if they ask for 2, like, or like 3s and 4s, because they don't.
Those are mutually exclusive.
Yeah.
Okay, and what's the other one?
Dependent and independent. If the first one changes the second one's sample space, they are dependent.
Okay.
Okay, we're good on that page.
Yep. Okay.
Next, top of this page is 1/12. 17 is 1/20th. 18 is 30 out of 133. 19 is that .006 again.
Yep.
0.006 again for 20.
That's the same idea that you just explained, isn't it?
This one is 28 out of 52. I'm on 21.
What's the decimal for that?
I don't know.
0.53.
Yeah, a little over half. Well, here's my 2 numbers. Take a look. 205 out of 900 times 204 out of 899.
Okay, how do you do those?
You got to look. I'm looking for an unemployed woman and an unemployed woman. So I have 900 people to pick from first. How many of them are unemployed women? Okay, so I got 205 out of 900 for my first problem. I picked that person. Now it's probably going to pick another one. 204 out of 899. Next one was not a married man and not a married man. There are 489 people out of the 600 that are not married men.
Oh, dang, that's dead wrong. It is backwards.
And then 488 for the second one.
Aren't you supposed to do 1 minus for that one?
Nope, I'm just looking for not a married, do you agree that I'm only looking for not married men and not married men?
Right.
Okay, so if I look in here, it doesn't really tell me how many are not married men, but it tells me that there's 111 married men. That means the rest of them are not married men. Do you see where I got my number from? I took the 600 and subtracted off those 111 married men. That means the rest of the group is not a married man.
Oh.
Cool.
Make sense?
Yeah.
Guys, it's kind of logic, isn't it?
Yeah.
Dylan was trying to explain it to me the other way, and I'm not
Oh,
getting it.
I'm looking, all I do is say I'm looking for not married men. What do I know? Oh, there's 111 married.
Quiz now?
No, not yet.
Patience, Dean.
So do you not have to do 1 minus on any of them?
Only if it's at least 1. That's your phrase for 1 minus.
They were telling the 6 hours telling me that if it's neither, you gotta do 1 minus.
No, they're wrong. Okay,
I like hearing 6 hours wrong.
so not an overweight woman and not an overweight woman. So I went in here and said, ooh, 54 are overweight women. So if there's 300 people and 54 are overweight women, when I subtract 54 off, that means there's 246 people that are not considered overweight women. And then you got the 2.
21.
21. Oh, this is a bad question. I considered it not a red card, so black, or actually picking a 2. I didn't consider it not a 2.
Oh.
This is a bad question because you can interpret it either way. I would not give you one that's ambiguous like this.
Yeah, I minus it by 1.
I'm surprised you knew how to use that word. You're usually bad with this.
Oh, ambiguous, not clear. This is a not clear question. So it depends on how you thought of it. You could have had a right answer if you did not a 2.
Yeah,
Okay.
that was not red or
Okay.
Wait till it's 1 page.
So while they're taking their quiz, you can come look at my homework, please.
All right, and then these ones here. We didn't go over what this meant here, but were you able to figure it out?
No. Yeah.
Oh, okay, and these aren't hard. It says you got 100 Scrabble tiles. You're going to pick 2 tiles without replacement. What this is saying, what's the probability you pick an H tile given that I already picked an A tile? So this is the second tile given that this first tile is here. And I should have talked about this page before. These are actually super easy.
Oh, you got it.
Let's go down to the table ones though. I don't even care about these ones in here either. I didn't finish that.
Can you explain 15?
Yeah.
15. This one?
Yes.
What's the probability of picking a 4 given that a spade has already been picked out of the deck?
What if it was a 4?
I know. I don't even know what you do with that. I just assumed it wasn't.
I just
Okay.
said 4.
We're not going to have any of those.
No. I agree that, I mean, I kind of, what if it was a 4 of spades? It'd be 0.
Okay.
Or
B, 18.
0, maybe there's 2 answers for it.
Wait, how would it still be 0?
Because you already picked the 4 of spades, so you're not picking.
Oh, now it would be 0. It would be 3 out of 51. Sorry, 3 out of 51.
But there's
Maybe there's 2 answers for that.
Okay, that's what I did.
I guess that's the best way to do that one. I don't really know the answer to that.
I'm going to tip it over here.
Okay, then you had these 3 questions.
Do we have to draw a tree on any of them? Otherwise?
Not if you don't want to. 26 out of 49 for your first question. 90 out of 143. And, oh, I didn't do the final answer. 90 plus 94 minus 64.
120 of 0.839.
How many is it? 120?
Yeah.
Over 143. Any questions there?
Can we take the quiz now?
No, I'm ready.
Any questions on that?
Nope, nope.
We don't have much time to take
Okay,
the quiz.
I'll take the review packet. Use your note card.
Ms. Schwartz.